In this video, we're going to cover section 2.3. We're still testing arguments for validity using the true-false method, but now we're going to incorporate equivalences. So sometimes it's not possible to determine the truth value of our simple statements in an argument using the direct approach like we did in the previous video. And this happens when all of the premises are disjunctions, conditionals, or biconditionals, since for each of those, there's more than one way for each of these statements to be true. So it's not going to be so obvious to, be able to, or possible to come up with the truth values of our simple statements. So when this is the case, it's often useful to replace a statement used in that argument with another logically equivalent statement. And you'll see what I mean when we start going through these examples. So let's start with using the conditional equivalence. Let's test the following arguments for validity. If it's invalid, we're going to do what we've been doing and produce a counterexample chart. So let's look at this first argument. We have two premises. And remember, with the true-false method, we're going to assume the premises are both true. But here's the problem. We have two conditional statements, right? And there's different ways a conditional statement can be true. It could be true implies true, false implies false, false implies true, right? So there's too many different possibilities for P, Q, and R. So rather than drive ourselves nuts, let's use an equivalence. And the reason that I'm thinking that we should use the conditional equivalence is because both of these premises are conditionals. And let's just go back for a minute to our conditional equivalence. Remember, and we learned this back in chapter 1, what the conditional equivalence says is that P implies Q is equivalent to not P or Q. And the reason I'm thinking this is because look, you see how we have not P implies not Q, right? I have that conditional statement. And then right above it, I have P or not Q. That's the conditional statement right there, right? So not P implies not Q is the same thing as not P, right? Negate the left-hand side, which is P, or, and then Q, the right-hand side, which is not Q. And that's what we have right here. So the value of this conditional is equivalent or the same as P or not Q. And what do we know about not P implies not Q? Well, it's true, right? We're assuming it's true. Therefore, P or not Q is also true. And in order for this premise to be true, because it's part of a conditional, the right-hand side R has to be true. Otherwise, we would have true implies false, and it would be a false premise. So R is forced to be true. And my conclusion is R, which is true also, right? If R is true, then R, the conclusion, is also true. So we just showed that this argument is valid using the conditional equivalence. Let's try another one. In the one on the right now, we have three premises, which we're going to assume are all true. Again, I have the first two premises are conditional statements. The third one is a disjunction and or statement. And there's too many different possibilities for P, Q, R, and S in order to assume that these premises are all true. So we're not going to use the direct approach. Let's try to use an equivalence to help us out. And again, the reason I'm thinking conditional equivalence is because I have a few conditional statements in here and I see an or statement, right? Because if we know P implies Q is equivalent to not P or Q, and I see an or statement in there, let's see if they're equivalent. So I have P implies Q right here. That's the left-hand side of the first premise. That's equivalent based on my conditional equivalence to not P or Q, right? Which I have right here. So if not P or Q is true, then that means that P implies Q is also true since they're equivalent. So the left-hand side of this conditional statement in the first premise is true. And in order for the premise to be true, then that means R has to be true, the right-hand side as well. It can't be false, or else the premise would be false. So then that leads me to say, okay, the left-hand side of my second statement, my second premise is true because it's R. And not S, which is the right-hand side, has to be true in order for the premise to be true. Otherwise, I would have true implies false. So not S is forced to be true, and not S is my conclusion, which is also true. So again, I have my premises, which are all assumed to be true, and a conclusion that's true as well. So that argument is valid. So things to look for when we can't use a direct approach and we're going to maybe try using equivalences. Think, okay, conditional equivalence, I have to have a conditional statement in there, right? But then I'd also have to have an or statement in there and check and see if they're equivalent, right? Using the conditional equivalence. And if they are, go ahead and use it. There's going to be times when we could use the contrapositive equivalence. And we learned that in chapter 1. And let's just remind ourselves of the contrapositive, right? So if I have a conditional statement, P implies Q, that's equivalent to not Q implies not P. So let's keep this one in mind and let's look at this first argument. I have 3 premises, which I'm going to assume are all true. There's too much going on here for me to use the direct approach. I can't directly figure out any values of P, Q, R, S, or W because there's too many possibilities for these conditional statements to be true. Again, we have conditional statements here, so let's think, okay, maybe I can use possibly the conditional equivalence or maybe the contrapositive because that also involves conditional. And what I'm thinking is when I look, these are the things you should look for. So you see how before in the ones we were doing above, we had an or statement. So we were using the conditional equivalence. In order to have an equivalence for this or statement, not P or S, it would have to be P implies S, right? But I don't have that here. I don't have that conditional statement. So I'm not going to use the conditional equivalence, but I do see a not Q and an R, but then I have a not R and a Q, right? So I'm thinking, okay, they're negated and they're reversed, contrapositive, right? So the contrapositive of not Q implies R would be not R implies the negation of not Q, which is this guy right here. So not Q implies R is equivalent to not R implies Q by the contrapositive equivalence. And we know that not R implies Q is true. Therefore, not R implies Q is going to be false, right? Because not false is true. So not R implies Q is equivalent to not Q implies R, and we know it's false, so that's false also. And the only way a conditional statement can be true if the right-hand side is false is the left-hand side has to be false. So that makes P false. And then not P, which is right here, would be true. And it's in an or statement, right? So that automatically makes the left-hand side of this conditional true, since half of the or statement is true, right? It's going to make the statement true. And then that forces W to also be true. Because if it wasn't, we would have true implies false, which would be false, but we want this premise to be true. And W is the conclusion, and we already figured it's true. Therefore, this leads us to a valid argument, since when my premises are true, my conclusion is true also. So let's look at the next example. Let's assume our three premises are true. Let's see if we could use some sort of equivalence that involves conditional statements, because I have a conditional in each one of those premises. I don't see an or statement. So I'm thinking, okay, I'm not going to use my conditional equivalence, but I do see two equivalences that look like contrapositives, right? So if I have not R implies Q, the contrapositive of that is going to be not Q implies R, right? Which actually is this guy right here. So they're equivalent. So if the second premise, not Q implies R, is true, then that makes the left-hand side of the first premise true. And that's going to force S to be true, right? Because if it was false, then the premise would be false, and that's not the case. So then S down here is true. And it's the left-hand side of a conditional, and we want this conditional statement to be true because it's a premise. So then that's going to force R and W to also be true. And the only way a conjunction, right, an end statement could be true is if both R and W are true. So if R is true and W is true, that will lead my conclusion, not W, right, to be false. Therefore, I'm going to have an invalid argument, right? So now let's come up with our counter examples. So let's list our variables, right? We have Q, R, S, and W. So let's think about what we know these values have to be so far, right? So we already said, okay, R and W had to be true, which makes R was forced to be true, right? And W we said is true. And we also figured that S is true also. And if we look at the second premise, because the only premise, well, the first premise and the second premise involve Q, right? So now we're trying to figure out, okay, what values of Q are going to keep the premises true, right? But the conclusion false. So R we already said is true, right? So the second premise, the right-hand side is true. And not R, we said is false then if R is true. And this left-hand side of the conditional is a conditional, right? And we have false implies Q, because we still don't know what Q is, but this statement has to be true. So Q could really either be true or false in either case. So we have to consider both cases. So it doesn't really matter. It's not going to change anything. If Q was false, we'd have false to false, which is still true. And if Q was true, false to a true is still true. And the same thing over here for the left-hand side. If the right-hand side is true, right, doesn't matter what the left-hand side is, the conditional is going to be true. So Q could either be true or false. So Q is either going to be true and the rest of the values are also going to be true, or Q could be false while R, S, and W are still true. So those would be our two counterexamples. It's also possible to use De Morgan's equivalence if we had to when we're testing an argument for validity. So let's write down De Morgan's just so we have it in front of us as a reminder. And again, we went over De Morgan's equivalence in the first chapter. So if we negated an or statement, so if we had not P or Q, that's equivalent to not P and not Q. And if we negated an and statement, a conjunction, not P and Q, that would be equivalent to not P or not Q, right? That's what De Morgan's equivalence states. So let's see if we could apply that to these two proofs. So we have on the left, this argument has three premises, right? So let's assume they're all true. And right away, I see that I have an and statement, a conjunction, and it's being negated, right? We have not QND. So if we applied De Morgan's equivalence to that, that would be not Q or not D, which is exactly what I have as my third premise. So that means that the third premise, which is true, has the same truth value as not Q and D. So we could say that that's true also. And that's the left-hand side of a conditional, right? And we want that conditional statement to be true, so that forces G to be true. Because if G were false, I'd have a false conditional statement. So then G up here is also true. That's a conditional statement. It's a premise, so I want it to be true. So then that means not M has to be true. Otherwise, if it was false, I'd have true implies false, which is false, but we need it to be true. So if not M is true, then that makes M false, which is the left-hand side of the conditional in our conclusion. And that automatically makes the conclusion true, right? Because it doesn't matter what P is. If P was true, we would have false implies true, which is true. Or if P was false, we'd have false implies false, which is also true. So no matter what, it's making our conclusion true. So we have a valid argument. So let's do another one. So for this next example on the right, we have three premises. I'm going to assume they're all true. And I'm just observing, I'm looking to see if possibly I could use the conditional equivalence or the contrapositive or maybe De Morgan's. Obviously, this section is focusing on De Morgan's, but if this was just a random question and you needed to go through this and try to figure out how to label, you know, P, Q, R, S, and H, and you're having trouble, think of equivalences. Now, I see an and, I see an or, and I see negated value. So I'm thinking, okay, maybe De Morgan's, right? So look, if we were to negate the second premise, not Q or R, right? we would apply De Morgan's and we would have Q and not R, which is exactly what we have right here, right? So Q and not R is equivalent to not Q or R. And that value is false, right? Since not Q or R is the premise and it's true, the negated version of that would be false, right? And the negated version of that or statement is Q and not R, which is this statement up here. So that would be false as well. Now, that's the right-hand side of a conditional. In that first premise, it's false. So the left-hand side can't be true, or else we would have a false premise. So that forces not P to be false. Therefore, P, so if we look at the third premise, you see how we have P. Let's just get rid of this to clean this up a little bit. So if not P is false, then P is true. If the left-hand side of a conditional is true, then the right-hand side has to be true in order for the statement to be true. And for an end statement to be true, both sides of the conjunction have to be true. So that forces S to be true and H to be true. And H also happens to be the conclusion. So that would be true also. So we just showed that when the premises are all true, the conclusion has to be true as well. So we have a valid argument, and we were able to use De Morgan's equivalence. The other possible equivalence that sometimes is helpful is the conditional negation equivalence. That, again, we also covered in chapter 1. So let's just remind ourselves of what the negation of a conditional looks like, right? So if I negate P implies Q, that's equivalent to P and not Q. So let's keep that in mind and let's test the following arguments for validity. So let's look at the one on the left first. I have two premises. We're going to assume they're true. Now, they're both conditionals, and it's too tough to say, okay, which side of the conditional has to be true or false in order for the premise to be true. So we're going to have to not, use the direct approach. We're going to have to maybe use equivalences right now. But I see a conditional statement. You see how we have P implies Q, and I see it's being negated. So I'm thinking, okay, we're negating a conditional. What would that be equivalent to, right? Well, that would be equivalent to P and not Q, right? That's the negation of a conditional, and we have that right here. So these two statements are equal in terms of their truth value. So if not P implies Q is true, then that means P and not Q is true because they're equivalent. So the fact that the left-hand side of this conditional is true, that forces the right-hand side to also be true. It can't be false, or else the premise would be false. Now, we can also say, since this left-hand side, the P and not Q in the first premise is true, the only way a conjunction, an end statement is true is that both the left-hand side and the right-hand side are true, right? So that means that not Q is true and P is true. But now this still leaves us with R and S, right? Like I know what P is. P has to be true. Q has to be false, right? Because not Q is true. So we know the value of P and Q. I don't know R or S. But I know that this R or S has to be true, right? So they both can't be false because false or false is false. So we can either have R is true, S is true, R is false, S is true, right? But what instance do we care about right now? Well, we want to show, is there a possibility that depending on what R or S is, right, each one of those values, is it possible that the conclusion, because the conclusion is R, right, that it could be false? Well, we kind of just said, yeah, that is possible, right? Because R or S has to be true. Well, what if R was true? If R was true, the statement would be true, right? True or anything is true. And then that would make the conclusion true. However, what if let me use red. What if R was false? If R was false, then that would force S to be true, right? Because that's the only way this or statement could be true. But my conclusion would be false. And that would prove that this argument's invalid, right? So since there is a possibility that R is false while keeping the premises true, that would make the conclusion false. So this argument's invalid. And the counter example would be the following. So we have P, Q, R, and S. So we know P is true. We said that not Q is true, so Q is false. And in order to have a false conclusion, that would mean R is false. And if R is false, that makes S true. So that would be my counter example. And let's do one more. So this last example, we have 4 premises. Let's assume they're all true. Kind of got a lot going on here, right? I see a lot of conditional statements. I see an and statement, 2 of them. I see a couple of or statements. So I'm thinking I'm definitely going to have to apply equivalences here because it's going to be too hard otherwise to try to figure out all the different values, right? For the variables for P, Q, R, S, M, W, C, right? A lot going on. And there's really no direct approach here to figure out what each one of these values are. I'm going to start with the single statement in premise 3, right? You see how I'm drawn to it because it's a single conditional statement, but I see it's being negated. So let me see if there's an equivalent statement anywhere in these other premises, right? So not P implies Q is equivalent, and we have it up here, right? It's equivalent to P and not Q. And look, I have a P and not Q right here. It's the left-hand side of the first premise. So if we're assuming not P implies Q is true, then P and not Q, since it's equivalent, is also true. And that's the left-hand side of a conditional. And the conditional we're assuming is true because it's a premise. So that forces S to be true. Can't be false, or else the premise would be false. And the end statement on the left, since we already know it's true and it's a conjunction, that means that both the left and the right-hand side have to be true. So that makes P true and not Q true. We said S is true, right? So S is true, which makes this or statement true, right? Because with a disjunction, just one side has to be true for the statement to be true. And that's the left-hand side of a conditional statement, which we're assuming is true because it's a premise. So that makes not R or M true. Now, that's not really going to let us figure out what R and M are, right? Because it's in an or statement and just one side of the statement has to be true in order for it to be true. But what I'm thinking is, because I know that that statement is true, right? Not R or M, that disjunction for the right-hand side of that second premise. I know it's true, even though I can't tell yet what not R or M have to be. But I also see an R over here and a not M over here, and it's not an or anymore. It's a and. So I'm thinking, maybe this is De Morgan's, right? So what if I negated not R or M, right? So what if we negated the right-hand side of this conditional in the second premise, not R or M? If we negated it, then that would be not R, which is R, and a not M. And that's exactly what we have right here. So it's the negation of this statement up here. And it's true. So the negated value would be false. So we just figured, okay, R and not M is false because it's the negation of not R or M, which is true. And the fact that R and not M is false and it's the right-hand side of this conditional statement, right, for the fourth premise, and we're assuming it's true, C can't be true. It has to be false in order to keep that premise true. So if C is false, then not C, which is the conclusion, is forced to be true. So when our premises are true, our conclusion is true as well, and this argument is valid. So now that we did a whole bunch in this section, right? We did a couple of examples of each. We did the conditional negation equivalents, the conditional equivalents, contrapositive, and De Morgan's. These are the things to look for when you're working on the homework questions, right? Think about, okay, what can I apply here out of the equivalences that I know? So especially when you see a lot of conditional statements, think possibly contrapositive, or was there a conditional that was negated, right? If you see ands and ors, think, okay, maybe De Morgan. So the more practice you do with these, the more obvious it'll become as to kind of when to look to apply these equivalences. But I feel like in this section, we did, a variety. We did a bunch of different examples. So now you'll be able to attempt the 2.3 homework and try some of these on your own.